In this video we will look at implicit functions. Suppose we have x squared plus y squared equals 9 and we'd like to find the derivative. Well, one thing we could do is differentiate each term. That is, derivative x squared, derivative y squared and derivative 9. We know the derivative of x squared, we know the derivative of 9, but what is the derivative of y squared? Well, this approach is not always necessary to find the derivative of y. Let's look at another way you could find the derivative of y for these types of problems. Let's look at a similar example. Suppose x squared plus y squared equals 25. This equation is in implicit form. We shall rewrite this equation into explicit form. Implicit form is when the x and y are tied up on the left. Explicit form is when we know what y is in the form of y equals, that is, explicitly. So, we will need to get y by itself on the left. We will take x squared over to the right, as shown, and then take the square root. So we have y equals plus or minus root 25 minus x squared. This is now in explicit form. Changing the square root to power a half, we are now ready to find a derivative. Derivative of y is plus or minus the power brought down. The power then now is reduced by 1, and we multiply by the inside derivative, which is minus 2x. This is the derivative of y. The problem with this approach, it is quite time consuming and indeed not always possible to change your equation from implicit form to explicit form. You may think the derivative of y squared is something simple like 2y, that it's just as straightforward as that. Indeed, it is easy, but not quite as easy as that. Let's see why not. Suppose y equals x cubed. Then we have derivative of y equals 3x squared. Now let's calculate y squared. It'll be x cubed squared, which is x power 6. And the derivative of this will be 6x power 5. So the derivative of y squared is 6x power 5. Note that this is not 2x cubed. That is, this is not 2y. So the derivative of y squared is not 2y. What is it? Let's find the rule. We want to find the derivative of some function of y. That is, d dx, some function of y. We'll multiply by dy over dy, which is just 1, so no change has really taken place. Notice in the denominator we have dy times dx. We'll just swap that to dx times dy. Again, no change since multiplication can be reversed and nothing is affected. But dy over dx is the derivative of y. So we can see here that the derivative of some function of y is just the normal derivative multiplied by y derivative. So to find the derivative of a function of y, we do the normal derivative, but then multiply by derivative of y. Let's look at an example. Find the derivative if x squared plus y squared equals 9. We shall apply the derivative to each term, derivative of x squared, derivative of y squared, and the derivative of 9. Derivative of x squared is 2x. Derivative of y squared is 2y, multiplied by y derivative. Remember, whenever we do a y derivative, we have to multiply by y derivative. That is, the derivative of y squared is 2y, the normal derivative, multiplied by y derivative. And derivative of 9 is 0. Divide everything by 2. And we see we have x plus y times y derivative equals 0. Take the x over to the right, becomes minus x, and divide by y. And we have our answer. Y derivative is minus x over y. Find the derivative of y if x squared plus x sine y equals 16. Pause the video and try this question. Resume when you're ready to see the answer. X squared plus x sine y equals 16. Differentiating each term, derivative of x squared plus the derivative of x sine y equals derivative of 16. Derivative of x squared is 2x. And then we have to do the derivative of x sine y, and that will equal derivative of 16. So we have 2x plus derivative of the first function, keep the second function the same, plus the first function, and then do derivative of the second function. This will equal derivative of 16, that is, it will equal 0. 2x plus 1 sine y, since derivative of x is 1, plus x, and now the derivative of sine y is cos y, normal derivative, and don't forget we need to multiply by y derivative, and this will equal 0. I will take the 2x plus sine y over to the right, they will become negative. You see, I almost have the answer, I just need to divide by x cos y. So I have y derivative equals, taking the minus outside, 2x plus sine y over x cos y. What is the tangent to the curve 25x squared plus 9y squared equals 34 at the point 1, 1? (25x squared plus 9y squared equals 34). Doing the derivative, we get 50x plus 18y, and then remembering to multiply by y dash, equals derivative of 34, which is 0. Taking the 50x over to the right, and it'll become minus 50x. And then we divide by 18y. So we get y derivative equals minus 50x over 18y. Now we evaluate this at the point 1, 1. So we get y derivative equals minus 50 over 18. And therefore, the slope of the tangent will be minus 25 over 9. M is minus 25 over 9. Now we use a point to find C, that is the point 1, 1. The equation of our tangent so far is y equals minus 25 over 9x plus c. We shall substitute in the point 1, 1, and we get 1 equals minus 25 over 9 plus c. Taking the minus 25 over 9 to the left, it'll become plus 25 over 9. So we have 1 plus 25 over 9 on the left, giving us the result that c is 34 over 9, and now we have our final answer because we have found both m and c. That is, y equals minus 25 over 9x plus 34 over 9. What is the tangent to the curve x plus xy plus y equals 3 at the point 1, 1? Pause the video and try this one. Resume when you're ready to see the answer. X plus xy plus y equals 3. Differentiating, we have 1 plus xy derivative plus y derivative equals 0. We shall need the product rule now. 1 plus derivative of x, the first function, which is 1, we keep the y the same, and then keep x the same and do the derivative of y, which is just y dash, that is y derivative, plus y derivative equals 0. Take the 1 plus 1y over to the right. So we have xy derivative plus y derivative equals minus 1 minus y. On the left, y derivatives in common to both terms, we can factor this out, giving us the result that y derivative times x plus 1 equals minus 1 minus y. And so we have y derivative equals minus 1 minus y over x plus 1. Evaluate this at the point 1, 1, and this will give us the slope of our tangent, that is m equals minus 1. So we have y equals minus 1x plus c. This is the equation of the tangent, and all that's left to find is the c. We find the c by using a point, and the point is 1, 1. Putting in the point 1, 1, and we have 1 equals minus 1 plus c. Taking the minus 1 over to the left, we get c is 1 plus 1, which is 2. So now we have our answer. The slope is minus 1, the c is 2, and so the equation of the tangent is y equals minus 1x plus 2. That's all for implicit functions.